Okay, for this question, they said on graph paper you can do this, but we can actually do it without graphing, right? Because A says predict. So they give us these three coordinates, and then which if I graphed it and connected it, it would be a triangle, right? And then it says predict the coordinates for A of the shape after it's translated 3 units to the right. So A, X is going 3 to the right. So that's going to be plus 3 in the X direction. And 1 unit down. So in the Y direction, it's going to be 1 unit down, which is subtracting 1, right, from each of the coordinates. And then it says, what are the three? So for the first one, negative 2, 1, it would be negative 2 plus 3, comma, negative 1 minus 1. So the first ordered pair would be 1, negative 2. 1, negative 2. And then the second one, I'm not going to show the work for it, but it's 1, 2. So it would be 1 plus 3, which is 4, and 2 minus 1, which is 1. So there's the second one. And the third one is negative 2, 3. So it would be negative 2 plus 3. Again, the same as the first one, which is 1. And 3 minus 1, which is 2. So there's the three ordered pairs for the translation. And if you graph those, you would see that indeed, yes, they are correct. Then it says dilate the original shape. So again, we're back to the original 3 points by multiplying both the X and Y coordinates by 2. So again, multiply by 2. So negative 2 times 2 is negative 4. And negative 1 times 2 is negative 2. So there's the first point. The second point is 1 times 2, which is 2, times 2 times 2, which is 4. And the third point is negative 2 times 2, which is negative 4, and 3 times 2, which is 6. So this is for B. So this is A, right? This is B. And then for C, it says reflect the original shape over the y-axis. What are the new coordinates? Okay, let me make some space here. Okay, so I drew this quick graph and I plotted on there the first point, this negative 2, negative 1. Now they want us to reflect it over the y-axis. So I want to do it for 1 point just so you see what happens. When we reflect it over the y-axis, it means we go to the y-axis, right? And then the same distance away on the other side, which brings us to here. So in essence, what we're doing is we are now, we're now at 2, negative 1. And we were at negative 2, negative 1. What we really are doing is we are taking the opposite of the x value, of the x coordinate when we reflect over the y-axis. So I can quickly see, for the first point, it's 2, negative 1. And then without even graphing the rest, the 1, 2, we're going to make it negative 1, 2, because, again, we're taking the opposite of the x value. And then for the last one, it's negative 2, 3, and it becomes 2, 3, because, again, we're taking the opposite of the x value. For these kinds of problems, I recommend actually drawing it for one of the point and seeing what happens. See, we quickly saw that this negative 2 became a 2, right? And if I started with 2, negative 1 and flipped it over the y-axis or reflected it, it would have become negative. So we could quickly see that we're actually just taking the opposite of the x coordinate.